Hello everyone. In this video we're going to begin section R.4 which is on polynomials. And so clearly you've seen polynomials before. We've actually worked with them in this class before, but we've never really studied them in the way that we're going to now. So let's first start with the term monomial. And so here's the definition straight from the book. A monomial in one variable is the product of a constant and a variable raised to a non-negative integer power. A monomial is of the form a times x to the k, where a is a constant, x is a variable, and k is greater than or equal to 0 and is an integer. We call that constant out in front of the x the coefficient of the monomial, and if a is non-zero, then k is the degree of the monomial. Okay, so the degree is the thing above the x, and the coefficient is the thing out in front of the x. Okay, and so here are some examples. The first one is probably the easiest, 2x to the 6th power. The coefficient is the number out in front, so the coefficient is 2, and then the degree is whatever x is raised to usually. Okay, and so x is raised to the 6th power, so the degree is 6. And now I have some more interesting ones here, more interesting examples. What about the monomial 3? Okay, 3. Well, the coefficient is the number out in front, and so the number out in front is 3. Okay, but then the trickier part is the degree. Okay? And so you can rethink or rewrite. A monomial needs to be in the form a times x to the k, as they say above here, and so it's got to be 3 times x raised to the something power. Okay, and so I need to get to just 3. I need x to the whatever power to equal 1, because then it'll be 3 times 1, and so I get 3. It turns out that the number that you raise anything, so anything raised to the what power is 1. It turns out that the number that does that is 0. Okay, so it turns out that we can rewrite 3 as 3x to the 0th power. Okay? And so the degree is 0. So if you run into a monomial that has no x in it, the degree is going to be 0. Okay, and then lastly, negative 5x. The coefficient is negative 5. And then, of course, if I just have x, that's really x raised to the 1st power. And so the degree of that is 1. Okay, so that's a monomial and how to read that. Now, let's talk about like terms. Like terms. So this is important when considering monomials together. So eventually I'm going to want to, and you'll see in this slide, add or subtract monomials and do algebraic operations with them. And like terms help us do that. Okay, so 2 monomials with the same variable, which is raised to the same power, are called like terms. Okay, and so here are some examples with what I mean. If we have 2x to the 4th, 2 times x raised to the 4th power, and negative 5 times x raised to the 4th power, those 2 monomials are like terms because they have the same variable, they both have x, and x is raised to the same power. Okay, so they're like terms because of that x to the 4th. As an example of 2 monomials that aren't like terms, I have 2x cubed and 5x to the 5th. They both have the same variable, x, but the x's are not raised to the same powers. Okay? So when you have monomials that are like terms, you can perform algebraic operations on them. And what I mean by that is you can add them, subtract them, do other kinds of stuff. And so I have two examples here that I'll go through very quickly. 2x squared plus 5x squared. What you do when you have these monomials that have like terms, when you add these two, you add the numbers out in front and the x squared stays. So 2x squared plus 5x squared is equal to 7x squared. Okay, and similarly, in our second example over here, I have negative 5x to the fourth minus 3x to the fourth. And so you do the stuff with the coefficients, not the x's or the degrees. Okay? And so the answer would be negative 5 minus 3 is negative 8. And so the answer is negative 8x to the fourth power. So you'll see that the x's and their exponents stay the same. The only thing that changes, or the algebraic operations that we perform, are on the coefficients. Okay, a few other terms that we're going to use a little later on are binomial and trinomial. The sum or difference of two monomials with different degrees is called a binomial, okay, because it has two different monomials. Okay, so bi is, of course, Greek or Roman for two, okay, and so binomial has two different monomials, and they have to have different degrees, because if they have the same, then you can add or subtract them, and you don't really have two things there. It's just in disguise. Three different ones with three different degrees is called a trinomial. A trinomial. And we're working up to what do you do, or what do you say after 2 or 3? You could say 4, which would be like a quaternomial, but it's easier just to say many, okay? And many in Greek or Roman is a poly. So that leads us to a polynomial, which we'll see next time. But first, to end this video, I have a your turn, okay? And so I want you to identify the coefficient and degree of the monomial 5x to the fourth, and then I want you to add the following monomials together, negative 5x cubed plus 4x cubed, okay? So that's the end of this video.